We are covering the proper procedure for recovering low-pressure refrigerants, a critical topic for your EPA 608 Type 3 certification exam. Low-pressure systems, like centrifugal chillers using R11 or R123, operate in a vacuum, which makes their service procedures unique. The exam will absolutely test you on the correct recovery order and equipment. First, you must use a recovery machine specifically designed for low-pressure systems. These units are built to handle the deep vacuums required and have safety features like a high-pressure cutout set around 10 psig to prevent overpressurizing the chiller or the recovery tank. Using a standard high-pressure machine is a common exam trap. It's not designed for this application and will fail to recover the refrigerant properly. The most critical point, and a frequent source of confusion on the exam, is the recovery sequence. For low-pressure systems, you must recover vapor first, then the liquid. This is the opposite of high-pressure systems, where liquid is often removed first to speed things up. In a low-pressure chiller, removing liquid first would cause a rapid drop in pressure, which could boil the remaining refrigerant so violently that it freezes the water in the chiller tubes, potentially causing them to rupture. The exam will present a scenario and ask for your first step. The correct answer is always to begin vapor recovery. After recovering the vapor, you can then proceed to recover the liquid refrigerant. Because these systems hold hundreds of pounds of refrigerant, this process can be slow. An average 350-ton R11 chiller can still hold 100 pounds of vapor even after all the liquid is gone. To ensure a complete recovery, you often need to heat the system. Refrigerant will saturate the oil at the bottom of the chiller. By circulating warm water, typically around 90 to 130 degrees Fahrenheit, through the chiller tubes, you can boil the refrigerant out of the oil. The exam may ask about this step, framing it as a way to speed up or complete the recovery process. Another key procedure is breaking the vacuum before opening the system for service. After recovery, the system is in a deep vacuum. You must never expose it directly to the atmosphere, as air contains moisture, which is the enemy of a refrigeration system. The correct procedure is to break the vacuum by introducing dry nitrogen into the system until it reaches atmospheric pressure. An exam question might trick you by suggesting the use of compressed air. This is always the wrong answer. A memorable phrase to help you on the exam is, for low pressure, don't blow the flow. Start with vapor, nice and slow. This reminds you that the process is different from high-pressure systems and that vapor recovery is the essential first step to prevent damage. Pay close attention to questions that compare low and high-pressure recovery methods, as this is where the test makers love to place traps. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.